Alright, kind of a wet day. Geez, it's supposed to be a 10% chance of rain. Anyway, yeah, it's just as crappy a day as possible. It's supposed to be the best day of the week. Anyway, it doesn't really matter. Onward and nowhere. So anyway, I thought I'd do a physics video, so yeah, if you're not interested in this kind of stuff, go away. So Warbles on a lot did a bunch of, I just want to talk about it just because it's interesting. I really should have the diagrams and all that kind of stuff, but it's just no one else is talking about anything else specifically. So this is where my brain is, because I've been thinking about this crap. So Warbles did a video, a few of them on magnetism, and the comments are funny, just in the sense that there's these people who still believe, in perpetual motion, and that somehow it's a big cover-up or something that's prevented anybody from inventing one of these perpetual motion machines and blah blah blah. And to be honest, when I was a younger man, I didn't believe there was a conspiracy, but I really thought, there's got to be a way, to get the value out of gravity. Because gravity just seemed like it seemed so forcey, and so it just seemed like if you made a Ferris wheel that somehow took a longer time to fall one way on one side and pick the stuff up a shorter way on the other side, that somehow you could steal some energy. That you could make some kind of lopsided flywheel and, steal the value of gravity. So anyway, obviously you can't, but I did try to do it. I didn't. I actually machined some pieces, actually made a device just to see if I could do it. And because I drew it on a piece of paper, and I said, oh yeah, it doesn't work. Anyway, it's just something I guess you have to get it out of your system, just because it just sits there screaming at you, I'm a force, and it really isn't a force. And that's the trick of this whole thing, this magnetism and gravity thing, and even electricity thing. We understand them as forces, but they're not. There's another thing happening. So anyway, I was thinking about the application of this idea into space and gravity, because the trick with momentum, like say if I shoot myself into space, you can't turn like an airplane can in an atmosphere, or a submarine in water. You can't just turn your flaps and decide to change your direction. You can't create your own synthetic mechanism for turning. All you can do is, if you're moving one direction, you can apply a force and move in both directions. So you can say, I want to go that way instead of this way. All I can end up doing is still going forward and then going sideways. So all I can do is go diagonally. But I can't turn myself around unless I stop my forward momentum and turn it into, create acceleration against that momentum, and then create new acceleration in the opposite direction. But the trick is, you can scoop into a gravity well, you can slingshot, as they say, around a planet or a gravitational body, and you won't steal energy from it, but what you will do is eliminate the need to change your direction with force. So what you'll be able to do is change direction, like completely reverse your direction, without losing any energy. So like when they shot themselves to the moon, they had enough energy to make the trip, but if they actually landed the ship on the moon, they'd have no way of, number one, overcoming the moon's gravity to get back away from the moon, but they'd have no way to fuel the trip home, at least not within like a year. It'd take them a year to get back home, because they'd have to recreate all their acceleration, and so they needed fuel to do that, and they obviously takes a lot of fuel just to get out of Earth's gravitational force, and so it's hard to have much fuel left over unless you put some in space ahead of time, but it's still a lot of fuel. Anyway, so the idea was, well, the solution is you get caught up in the gravity of the moon, just loop around it, and then shoot yourself, let go of the gravity in the homeward direction. And so what you've essentially done is, say if you went into the gravity at 50 miles an hour, you loop around and around and around, and then you come out of the gravity at 50 miles an hour. So you didn't lose any of your momentum, your speed, your acceleration, and you in fact, but you completely changed your direction. Is now opposite. So that's an interesting phenomenon. That's the catch of gravity, is that it's sort of behaving as if it was an atmosphere, and as if you could just change pitch and create a force that would change your direction. But even in an atmosphere, you lose a lot of energy in attempting a turn, especially when they'll create a complete change in your direction. So it's not a very good analogy. But it sort of lends to my point that there's something else going on here, in terms of what the matter itself is doing and what the energy inside the matter is doing. Because theoretically, you could also spin and tumble all you want in space, and it's of no consequence. There's no front of the ship anymore. There's no pointy end that's cutting through the space. Little toad, 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 little toad. I'm little toad. It's barking. Anyway, I learned a new trick. I do like little toads. Anyway, so it's kind of a toad day. So where was I? Yeah, so there's something like going on here, because you could have a spaceship that was basically just shaped like a stick, and its movement wouldn't matter if it's doing this, it's doing that, it's spinning this way, it's doing this way. It doesn't matter what it does. Its mass still moves in a direction, and it's kind of completely irrelevant what the pieces of it are doing. I think substantially. I'm not sure if end over end would matter. So if it was doing an end over end, it might actually pick up. Now there'd still be a center of gravity, and the center of gravity. There'd still be a center pitch point on which it was pitching, and that would be its still be its material center. Yeah. I suppose you could have a wobble in terms of its acceleration. I'm just not sure if you can move the center of gravity. Okay, that one I'm just not sure of. I just don't think you can move it by its tumble, so its tumble would have to be on its center of gravity. It would automatically be forced to tumble on its center of gravity. Yeah, like a gyroscope. It would be forced into a centric motion. It would have to spin on its center. If it was spinning off of its center, that would be like the magnets, that would be neutralized out of the system. It would pull that out. Yeah, because that would be forces against the other forces, and so it might lose a little bit of acceleration to create that dampening effect of forcing it onto a center. Yeah, so that would be what would be happening. So anyway, the point I'm getting to, though, so let's say if you want to accelerate in space, what's really happening is you're shooting something, some sort of exhaust. I don't even know if it has to be on fire. I don't know if explosive exhaust, I suppose it does matter because it's a release of more energy. And so that's the key thing you're doing. It's basically you're saying, like, you're going back to Newtonian type physics. It's this equal opposite reaction thing. So you're basically shooting the exhaust into space. You're accelerating it. You're pushing it out. And it's the fact that you pushed it out ends up pushing you in the opposite direction. So essentially you're not getting the full value of the energy expended. You're only getting half its value, because half of the value of the energy was used to move the flamey stuff that way, and and the other half was used to move your side of the equation that way. So you've only extracted 50% of the efficiency of the force, because you did have to push something into space. You launched it essentially, to create your equal opposite reaction in the direction you want to go. So again, we're talking about this, what's really happening to the matter. So you're expelling photons and atoms, mass, things with mass, and you push them out. And that somehow creates in your body a force, a condition, where the matter in the body that's expelling has now changed in some way, where its potential of all its mass is saying go that way. And again, I left a little comment in the last physics video that I thought was a good comment, is that matter can't move the speed of light because it already is moving the speed of light. The matter is made up of these photons that are caught in orbits. So let's say an electron even is 2 photons at least, or maybe more, that are moving in a twisting motion. Alright, so as they move through space, they lose some of their speed of lightness because the photons are circling each other. So they're twisting through space. And that twisting motion creates the appearance that they're no longer moving the speed of light. So an electron may move close to the speed of light because the twist may be very subtle, a very slow twist, and very slowly if their twist is very high. So if it has a high frequency twist, the electron can move very slowly, and if it's a slow twist, it'll move very rapidly because the electron is photons. Now the same for the atomic nucleus. I could argue, I do theorize that it is also made up of subatomic particles. Okay, it's a nucleus, so obviously subatomic, that are also in some arrangement. So they may seem like they're a particle, but no, they're really a particle that maybe is a photon that's just chasing its own tail, or it's a photon where 2 photons are looped into each other like 2 rings, or it's a photon in some other arrangement that enables the light speed to be trapped. So it's essentially like the spaceship going to the moon, just staying in a centric orbit, in a consistent, non-degrading orbit. It can just keep doing that and doing that and doing that for a long, long, long time. I don't know if it's really true for gravity, but it's certainly true for atomic structure, that things can be caught in orbits for a very long time, and that without degrading. And so the point of that was, just to illustrate it, just to get a mind picture of it, that it's all light. That's all matter is light. All matter is a quanta, you could argue, and that light itself is just quanta all moving in the same direction. So if I said a photon was a school of fish, it would be a school of fish where each fish is going exactly the same direction at exactly the same speed. And that would be a photon. And the individual fish would be what we call quanta. And if we had 2 schools of fish and they danced with each other as they swam, that would be an electron, or a neutron, or positron, or gluon, or fluon, or bluon, or whatever you want to call them. All the other bullshit that the people at the accelerator say they found. So that was another part of this. When they accelerate these subatomic particles, atomic nuclei mostly, they put them in this magnetic field and just keep pushing them faster and faster and faster and faster. What's really happening is they're degrading the matter. They're basically forcing a rearrangement because the internal particles, the fish, the individual fish, can't be accelerated. The individual fish are already moving at the speed of light. And so all you can do is change their direction. You can't change their fundamental structure. So to accelerate a subatomic particle near the speed of light, what you're essentially doing is breaking any twisting motion. You're taking the twist out and you're restoring them back to a linear fish. And certainly if they're caught up in some chasing their tail motion or some other motion that's connecting them to other subatomic particles, you know, the twisting is tied to the looping, is tied to the something else. All of that structure has to be broken down by the acceleration and replaced by fish moving in the forward direction. They can't have a dance anymore. You got to take the dance out of them. And so that's why it takes so much energy, you know, tremendous amounts of energy to move these tiny, tiny particles so fast. It's because what you're essentially doing is replacing the structure of the matter. You're replacing a fish that's going this way with a fish going this way, and are forcing fish out of the things that are bonding them into a dance, into an eccentric motion. So you're taking all eccentric motion out of the matter and restoring it to plain, all the fish moving in one direction. Now that's why the force of these particles when they hit the target seems so great and big, is because just like a school of fish, if all the fish are moving in one direction and they hit a wall, they'll apply all force in that direction. But if a bunch of the fish are swimming this way, and some are swimming the opposite direction, and some are swimming up and down, and they're swimming all kinds of directions, you won't have the same force impact. It'll be greatly reduced. So it's like a crowd of people. If a crowd of people is just bouncing off of each other, moving this way, moving that way, if you had 100 people and you push those 100 people into a wall, you wouldn't do anything to the wall. But if all the people at once, at the same time, all move towards the wall, there'll be a huge multiplication of their force impact on the wall, because they've neutralized any eccentric or wasted energy, not wasted motion or complex motion. They've taken all the complex motion out and restored it to a single linear, all the energy in one direction. A laser beam, so to speak, of energy. Yeah, so that's where I am so far. Yeah, mostly. I think it's come together, I really do. I think I'm just, a few million quanta away from resolution. Yeah, just right there, so close. Anyway, till next time, and such, so forth and whatnot.